So one of the main concepts in Sn2 reactions is something called an inversion. Now let's just make sure that we can do an Sn2 reaction. Well, first, for our substrates, these two are exactly the same. I just have the Newman projection of this one over here. Now let's check the steric hindrance. Now on this carbon containing the leaving group, which is bromine, it's a secondary carbon, and so it will allow Sn2 reactions. And if we look at the leaving group, bromine, this is a good leaving group, so it will work. For our nucleophile, we have the methoxide ion, and the methoxide ion is a strong nucleophile, so we are set. And the last thing we want to check is the neighbor of the leaving group. The neighbors are these two carbons, which is a secondary one and a primary one. And so there's not too much steric hindrance around the carbon containing the leaving group, so we're fine. Now, when we perform this reaction and the sodium methoxide ion attacks from the backside on this carbon, you can get a product that looks like this. Now, the reason I'm writing a dash instead of a wedge for our methoxide group is because it's a backside attack, and that's what an inversion is. It's basically, if you're on a wedge for a leaving group, the sodium methoxide is going to come from the backside, and you draw it as a dash. Now, if it's a Newman projection, we can do the same thing. We can have our sodium methoxide essentially attack from the backside, and we get our Newman projection that looks like this, where the two groups right here, these two groups, they're going to flip and go this way, essentially, and the methoxide group is going to be pointing down like that. So if I draw that, we have my CH3 that moves over here, my hydrogen that moves over there, and then our methoxide group going down, so OCH3. And then for the back carbon doesn't change, and so the hydrogen down there is still there, the CH3 on the back is still there, and the other hydrogen on the back carbon is still there. Now this is an eclipsed version, and we don't want to draw an eclipsed version. So for your final answer, you just want to rotate it a little bit, and so you get this answer where you have our OCH3, you have your other CH3, your hydrogen, and then for your back carbon you have your CH3, your hydrogen, and then your hydrogen. And so here we have the biggest groups are anti to each other, and so this is a valid possible answer.